Okay. Um, Hopefully you can hear me. I am in period 3, doing my math notes here. We're talking about horizontal, vertical, slant asymptotes as well as holes. If you have any questions throughout the video, please feel free to speak up, but you will be on the video. If not, then it's okay. We'll have a Q&A at the very end. All right, we're taking a look now at example number 2. In one of the previous videos, we did example number 1. First thing that we want to do with any of these types is we want to see if we can factor. If you can't factor the numerator, that's fine. You don't have to worry about it. But you at least want to try and factor the denominator. So is there anything that's going to multiply to give me positive 1 and add to give me negative 2 in the middle from the 2 up front? No, you can't actually factor this numerator. I tried it last class. It just didn't work. So we're going to let it go. So got my 2x squared minus 2x plus 1. And then I'm going to factor the bottom here. If I take out a 2, this leaves me with x squared minus x minus 12, which then gives me 2 times x minus 4 times x plus 3. And going back to factoring, you always want to try to factor just in case you have a hole. If you can't, you can't. No quadratic formula, nothing. You just leave it as is. So on this example, I'm looking for, since there's no holes, I'm looking for asymptotes. And I'm going to start with my vertical asymptote. Looks like I've got 2 vertical asymptotes. One at x is equal to 4, and one at x is equal to negative 3. So I'm going to go over here, and I'm going to graph those right away. Those are places where if I plug them into my equation, I would get 0 in my denominator. That's how we get a vertical asymptote. I'm recording right now, so can you wait until the end? Okay, thanks. All right. So there's my first 2 asymptotes. Yes. I know. It'll be okay. It'll wait. So next up is horizontal asymptote. Horizontal, you want to look at see the degree. So see how big the exponents are. If you notice, both of these exponents are the same, x of 2, x of 2. So I'm looking at my lead coefficients. So y is equal to 2 over 2, which is 1. And I'm going to go ahead and I'm going to plot that horizontal line there. So horizontal asymptote, not to confuse anyone, but a horizontal asymptote is an asymptote that you can possibly cross in certain situations. Everything else your lines will never touch. Horizontal asymptote's a little weird. Sometimes it will and sometimes it won't. So we're going to have to figure out what the shape of this looks like. I'm going to draw a T-chart. I'm going to plug in, I'm just going to put in my T-chart my first asymptote, negative 3, undefined. And then I want to pick a point to the left of it to kind of see where that point's going to lie. Because I'm either going to have a graph that's going to look like this or it's going to look like this, depending on where that point is. And I can put in 1 point. I can put in 2 points. It just depends on how much you want to check your work. So I'm going to plug in negative 4. And I'm going to plug it into either of the any of these that I solved. I usually plug it back into the original equation. That's just kind of how I usually do things. But it also takes me a little bit, just to do the math in my head. And I won't lie to you guys. Sometimes I make mistakes because I go kind of fast. So negative 4 squared is 16. 16 and 2 is going to give me 32. Plus 8 plus 1. So that gives me 41. So 41 over negative 4 squared is 16, so 32 plus 8 minus 24. So 40 minus 24 is 16. So 41 over 16. That's approximately like 2 and something. So I've got a point that's here. If I want to plug in another point, I can to double check myself, but my graph is going to look something like this. It's going to follow the curve. It will not cross because they are asymptotes. It will not cross. So now I've got to try something in the middle because my graph, just to show you what it could look like this. It could look like this. It could look like this. Or it could look like this. I don't know. Horizontal asymptote, again, is one where sometimes it could cross. It's usually, if it does cross, it's because you have two asymptotes. So I'm going to plug in points that are in between. I'll plug in negative 2, 0, and then my next asymptote's at 4, so maybe I'll plug in 3 into my equation to just see what that's going to look like. So in my equation, negative 2 squared is 4, times 2 is 8, plus 4 plus 1, so that gives me 13. Negative 2 squared is 4, times 2 is 8, plus 4 minus 24. It's going to give me 12, negative 12. So negative 13 over 12. If I plug in 0 into my equation, 0, 0, 1, and then 0, 0, negative 24, so negative 1 over 24. And then if I plug 3 into my equation, I get 3 squared is 9 times 2 is 18. Minus 6 plus 1, so that's 12, that's 13. And then 3 squared is 9 times 2 is 18. Minus 6 minus 24. So that's 12 minus 24. That's going to give me negative 12 again. That's weird how that worked out. Doesn't always do that. So let's go over here and plot the points. Bless you. Negative 2 is approximately like right there. 0 is negative 1/24th. And it looks like 3. It's going to be down here. And you know what? I'm sorry. I plotted this first point incorrectly. Should be closer to down here as well. So we're looking at our U, almost like a U shape. Following the curve. So where the x values come from? The x values have to come from some place around your vertical asymptote. So I'm plugging the x values into the equation to find the y values. So now I've got if you look, my next point would be 4. I've got an undefined because that's where an asymptote is. So I just want to plug 5 into my equation on something on the other side just to see where the shape is going to be to finish my graph. So 5 squared is 25 times 2 is 50 minus 10 plus 1. That's going to give me 41. And 50 minus 10 minus 24. So that'll be 40 minus 24, which is 16. So 41 over 16. That is funny how that kind of worked out. So 41 over 16 is approximately here, which means that my graph is going to follow the curve. Look something like this. Yeah.
How do you know that the curve curves out?
because I have that one specific point in that location, my graph will follow the curve, because essentially what it's doing is it's always going to be approaching it on each side of the asymptote. If I talk more about it, it's going to get into more like pre-calcy stuff. But essentially, if you don't believe that your curve is going to follow, you can always plug in more points. Like I can plug in 6 into that equation and see where that lies, and so forth and so forth. But for the most part, they will always follow. As of right now, they're always going to follow everything in there. Questions? Any other questions at all? I know it seems like a lot. Recap real quick. First thing you need to do, factor. Second thing, determine where your holes and asymptotes lie and graph those asymptotes. Okay. Last, create an XY chart, plug in points around those vertical asymptotes to determine where the shape of your graph lies. Can we try one with a slant asymptote? And then we'll be done pretty much for the day. Let's take a look at example number 3. I'll lead you through a slant asymptote, and then I'll hand out your homework assignment. You've got 3 problems tonight for homework. So first step, factor. I can factor out an x squared from the top, and then 3 plus x. And then in the bottom, x plus 3, x minus 1. So right now I have a 3 plus x and an x plus 3. So this becomes x squared over x minus 1. Your hole will be at negative 3. And then if I plug negative 3 into my x squared over x minus 1, I get 9 over negative 4, so negative 9 fourths. That's where my hole is going to occur whenever I graph. Take the hole and plug it into your simplified equation, and that'll give you your y value. So next up, asymptotes. Let's start with vertical. Vertical asymptote, there's going to be one where x is equal to 1. And then horizontal asymptote, let's look at the degree. So we've got a degree of 3 on top, and we've got a degree on 2 on bottom. So there's actually going to be no horizontal asymptote. When the degree is bigger on top than it is on bottom, there will not be a horizontal, there will be a slant. Okay? You can't have both. You can only have one or the other. So the way that a slant asymptote works is I'd use your simplified, and I would use synthetic division. So the x squared over x minus 1, divide it. So that's my x squared, and then 0x and 0. And then my bottom would become a 1. X minus 1, you'd solve it out, and you get x is equal to 1. That goes on the outside. Drop your first, multiply, drop, multiply, drop. This right here is your remainder. It does not matter. What you have here is the equation y is equal to x plus 1. That is your slant asymptote. So now I'm going to graph my asymptotes. I'm going to graph, first off, my vertical, x is equal to 1. And then my slant is just like a linear equation. I'm going to start at 1. I'm going to go up 1, up 1, up 1, up 1. And this is going to be my dash. Down, 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 down. So I factored, I determined my holes and asymptotes. Now I can use my XY chart to graph. So I need to graph things that are around my vertical asymptote. Put my XY chart down here. I've only got one vertical asymptote at 1. So I'm going to I'll find a point. I'll find 2 points on each side just to kind of show you how the curve goes. So if I plug 0 into either my original equation or my simplified equation, I get 0, 0. If I plug -1 in, I'm looking at my simplified because it's just easier for me to understand. It would be, but I'd have 0 on top. 0 squared is still going to be, so 0 over -1. -1 squared is 1. -1 minus 1 is -2. So -1/2. So if I graph those two right now, 0, 0, and -1, -1/2, I could kind of see where this is heading. And then if I plug 2 in here, I get 2 squared, which is 4, over 2 minus 1, which is 1. So I'll end up with 4. And 3 squared is 9. 9 over 3 minus 1 is 9 over 2. So 2, 4, and 3, 4.5. And there's my graph. And again, factor, find your holes, find your asymptotes, graph your asymptotes, and then do your XY chart. I think that's going to be the easiest way for you to do things.